Good morning, dear students. In last class, we studied about the acceleration and the combination of the harmonic functions are there. What is the equation of the displacement when the two harmonic functions are in combination? Like y is equals to a into sine of some angle is omega t plus of phi naught is there, plus of b into cos of omega t. If it is sine, the angle will change, or sine become what? Here b is there, sine become common here. If it is sine become common, because the angle should be same here. The particle which represents the simple harmonic motion, that its equation, it means the equation of the displacement should be the two combination. It means it is a combination of sine and cosine. Those sine and cosine should have the same angle. It means what? The same angle here. Then here the two amplitudes are there. One is along x-axis, another one is along y-axis is there. The two amplitudes are there. We have to find the resultant amplitude of these two, A and B. Resultant amplitude we already discussed in last class. Its form is nothing but what? Root of a square plus of b square. A square plus of b square is there. And the phase is there. What is the phase of these two? Their phase is the phi is equals to tan inverse of b by a is, we are already done in last class. Okay. Now, using these two forms, what is the total ratio of amplitudes and the phase difference of this given example? We have to calculate here. The first equation is given here, that is y1, the equation of the displacement which represents the simple harmonic motion. Y1 is there, its a solution. Y1 is equals to 10 sine of 3 pi t plus of pi by 4 is there. This equation in the form of what? Y is equals to a into sine of omega t plus of phi naught, or phi is there. Call it phi naught as a 1. Phi 1 is there. Consider as a phi 1. Okay, here amplitude is 10. Omega, angular frequency is 3 pi. Again 3 pi, all are 3 pi is there. Angular frequency is constant here. And here another one is phi. Phi 1 means the first phase is pi by 4. Then we have to write the given form here, given terms. First one is the amplitude, call this amplitude as A1. A1 is equal to how much? 10. We have to find the ratio of amplitudes, that's why A1 is there. Okay, it may be this in terms of meter or centimeter or something, because there is no unit given here. There is no unit given, so that consider as a meter. Okay. Another one is the angle, that phase, call it as a phi 1. That phi 1 is nothing but what? Pi by 4. This is about the first equation. The next equation is y2. The y2 is equals to 5 into bracket sine of 3 pi t plus of root 3 times of cos of 3 pi t. The angles of these two combinations, these two harmonic functions is same here, 3 pi t and 3 pi t. Expand the bracket. If you expand the bracket, this equation becomes sine of 5 times of sine of 3 pi t plus of 5 root 3 cos of 3 pi t. Now this is in the form of what? Y is equals to a into sin omega t plus phi naught of something or phi, directly omega t only. Okay, plus b into cos of omega t. This is in the form like this, because it has the two amplitudes, different amplitudes, a and b are there. So a and b are there. We have to find the resultant amplitude of these two, and we have to find the phase difference. Okay, phase of this one. First one, what is the amplitude, the resultant of these two? Y2 is there. The resultant of this one and this one, call it is the resultant amplitude of this equation. Okay, resultant amplitude, call this is A2, because here A1 now, so here resultant of this is A2. A2, our form is already there, that is a square plus of b square. A square plus of b square, a is nothing but here phi square plus of 5 times of root 3 whole square. Phi square is 25. Phi square is 25. Root 3 square is 3. 3 into 5. 3 into 25 is 75. 75 plus of 25 is 100. Root of 100 is A2 is equal to what? Again 10. 10 is A2. Here A1 is 10. Here A2 is 10. We have to find what? The ratio of amplitudes there. Amplitudes here. Okay. Then the ratio is A1 by A2. A1 is equal to how much? It is 10, and the A2 is also 10. Then these two gets cancelled. This ratio is 1:1. Then another one is we have to find the phase difference. Now the phase difference is, we have to find the phase difference, that is delta phi. But we have to find the first phase of this one. What is the phase of this given equation? Now the phase of the given equation, our form is already there. Phi 2, call this is a phi 2. Phi 2 is equal to what? Tan inverse of b by a. Here b is nothing but phi root 3. A is nothing but what? Phi. B is equal to tan inverse of b is phi root 3 divided by phi cancelled. Tan inverse of root 3. Tan yesterday root 3 andanga, it is nothing but what? Pi by 3. Because pi by 3 is nothing but 60. Tan 60 is equal to root 3. Then tan 60 is, it is phi 2 is equal to how much? The phi 2 is equal to pi by 3. We have to find the phase difference. The phase difference is nothing but phi 2 minus of phi 1. Phi 2 is calculated, that is pi by 3, and phi 1 is already given, that is pi by 4. Okay, yeah, we have to take the LCM of these two. LCM taking is nothing but what? The cross multiplication and denominator multiplication. The LCM is over. Cross multiplication is 4 pi. Here 3 pi. 4 pi minus 3 pi is 1 pi divided by 3 into 4 is 12. That is equal to pi by 12. Pi by 12 is the phase difference in terms of radian. Here it is in terms of meter. It is in terms of meter. Then ratio has no unit. There is no unit. Then here the phase difference is pi by 12. Like this, we have to calculate some examples on this combination of the any two harmonic functions, or simply like this. Okay, then I'll remove this one. Okay, and next problem is, I'll take the next problem. Before we have to take the example of the next example, we have to find the time period. What is the time period here? Very simple form is there. We have to check the time period of the simple harmonic motion, that is denoted as t here. Definition of time period is nothing but the total time taken by the particle to oscillate, the one to oscillate, it is nothing but 1 second, to oscillate in 1 second. So, or it is nothing but, what is the time taken to complete the one oscillation by the particle? To complete one oscillation, it is time taken. That is complete. It is what? The time period here. I'll write its definition. The time taken by the particle executing simple harmonic motion, executing simple harmonic motion to complete one oscillation. To complete one oscillation. The time taken for one oscillation is nothing but a time period here. But if it is traveling, if it is continuously rotating like this, to complete one revolution, the time taken is, that is called the time period. If it is traveling with the certain, the angular, it is continuously traveling with the velocity, that is linear velocity is v, but the angular velocity is nothing but what? The angular frequency, that is omega. It is continuously making certain distance, continuously covering a certain distance, but the acceleration is always what? Constant at the center here. Okay. We have to check if it is continuously moving with the acceleration and the displacement of the body, or if it is continuously, if it completes one revolution or one oscillation, its displacement is 0. But we have to take the equation of this time period by using the acceleration of a particle using executing simple harmonic motion. One is, first one, the acceleration of particle executing simple harmonic motion. Executing simple harmonic motion. Already we know that the given equation is equation, that is A is equals to what? Minus of omega square into y, where y is the displacement, A is an acceleration, omega square is the angular frequency square. Okay, but we have to take here the magnitude of this acceleration. Okay, its magnitude. Magnitude is A is equal to omega square into y. That magnitude is nothing but it is always positive. So then take here the omega square is equals to what? Omega square is equals to A divided by y, acceleration divided by the displacement of the particle. Then omega square is there, remove this square, then it become what? A root of the RHS. Then this omega is nothing but the 2 pi by t. 2 pi is nothing but the angle for one revolution. That is nothing but what? One revolution, one circle. That is 2 pi. Omega is equals to what? 2 pi divided by t. It is a time period here. Root of what? A by y. We have to take the time period. Take the time period to the RHS, and this become what? This become a denominator of the LHS and become the reciprocal of that. That become what? Time period is equals to 2 pi times of root of displacement become the numerator of that, and acceleration become the denominator of the equation. Finally, the time period of the simple time period of particle executing simple harmonic motion is nothing but what? The displacement divided by an acceleration. An acceleration is called what? The displacement of the particle. Its unit is the second, because time is there, because its unit is second. Then by using this form, that form is omega is equal to what? 2 pi divided by t. If number of revolutions are there or number of oscillations are there, it become into n is there. N number of oscillations. For n number of oscillation, 2n pi divided by t is there. That omega. Next, one more example. Next here, I'll take the one more example for the displacement here. First one is here, a simple harmonic oscillation has a displacement that is y. Amplitude A, that amplitude called is A, and the time period it is t. It is then the time required to oscillate from x is equals to a to x is equals to a by 2. Finally, it is x equals to a to x equals to a by 2. A is nothing but what? It is the maximum displacement. Up to a by 2, it become completely half of that. What is the total time required for that? Here we have to find initially. What is the first? We have to find what is the total displacement of that. It means it is called as the initial position and it is called as the final position of the particle. It's displacement. What is the displacement of the particle here? We have to find the total displacement, that is x2 minus of solution. That is x2 minus of x1 is equal to what? A by 2 minus of A is there. A by 2 minus of A is there. It means what? Take LCM, or you can take here A to A by 2, both are there. Then here it becomes what? A minus of 2A divided by 2 is there. It becomes minus A by 2. If it is minus A by 2, the magnitude becomes what? Minus of A by 2. Then I'll take the magnitude because it is a displacement, it is continuously moving, it is negative. Okay. Then here the magnitude, already it is negative, that's why it is taking minus, remove minus A by 2. But our displacement equation is x is equals to, you can take the sine or y, sine or cos here. But we are taking that equation always in terms of the sine harmonic function, so that x is equals to A is an amplitude. X is equals to what? A is an amplitude into sine of what? Omega t, na? Sine of omega t is there. Omega into t is there. Then the total time is the t is there, omega is also there. Then here we have to take the A into sine of omega is nothing but what? 2 pi divided by t times of t is there. Okay, we have to find the time required, that is this small t. We have to find the small t. But x is equal to what? The displacement is what happened? This is equal to A by 2. A by 2 is there. Then here A gets cancelled. If you take the sine or cos here, okay. If it is taking the sine function, that happened to become 1 by 2 is equal to sine of 2 pi by t is there because it is oscillating. Sorry, it is oscillating in x direction na, so we have to take the cos only. Sorry for that. Now take here the cos only. Our equation x is equals to a into cos of omega t. We have to find t here. X become what? A by 2. Then a is there, cos of omega is nothing but what? 2 pi divided by t into small t. Then here a gets cancelled. Here remaining term is 1 by 2. Then cos of 2 pi divided by t times of t is there. Cos inverse of, take here RHS, take cos trigonometric function to the LHS, that become cos inverse of 1 by 2 is equals to 2 pi divided by t into t. Cos inverse of 1 by 2, it is nothing but what? How much it is? Cos inverse of 1 by 2 is cos is 1 by 2 and then how that? It is nothing but what? Cos of pi by 3. Cos of pi by 3, cos 60. Cos 60 is 1 by 2, na? That's why. Pi by 3. Then it is 2 pi divided by t into t is there. Then again pi cancelled. If pi cancelled, what is the value of t here? This time period become the numerator of LHS, t is there, and here 2 is become the denominator of that become what? 6 is there. The total time is how much? T by 6 of this total time period. The total time period is t by 6. It means that particle is starts to oscillate like this here. If it is like this, the total time is t. The amplitude is maximum. It means what? The amplitude is maximum. It is completely maximum displacement is here a. If it is a, it wants to become the half of that, a by 2. Then what is the time taken? Okay, what is the time taken here? That is t by 6. Okay, these are the examples. In the next class we have to solve some more problems or some more examples, and after that we will go to energy. Thank you.